So last time we were talking about trigonometric functions. We actually discussed the graph of sine and cosine, and we talked about all of these notions of amplitude, period, the midline, and so on. So let us just do a little bit more examples because we didn't do too many. Okay, I'd like to do a couple more. So example, and again, I want you to find all of these quantities, and then we're gonna sketch the graph. Okay. Let's see, find the amplitude, find amplitude, phase shift, the midline, period, and then sketch. Let's see, I have some functions in mind here. Let's start as a refresh with y equals the sine of negative 2x. Then after that, we're gonna do a second one. Then let's do y equals, let's see, let's do negative 3 cosine of negative 2x plus pi. And then let's do minus 1. Okay. All right. So let's go ahead and let's graph. So let's answer the question for these two functions. Okay. So with this should bring back all the stuff that we did last time, and it's going to be a good summary to then move on to the other functions. All right. So solution. So remember, we have some formulas for all of these. First, let's find the quantities that they are asking us: amplitude, phase shift, midline, period. Okay, and we have some general formulas for this. So remember, the general form of the functions is the following. So for the sine function is a sine of bx minus c plus d, and for the cosine function, remember, it's the same thing. You just put cosine. All right, and there is a restriction here for this general form. What are the restrictions here? The condition is that we want b to be positive. That's the only condition. Okay, the rest stays the same. So our first job is to make sure that we have the function that we're given in this format. Notice that I purposely put a negative here and a negative here because I want you to understand how to deal with this if this were to happen. All right, so let's do this. The number one, the first one. So we have y equals sine of negative 2x. So the first thing is that we need to write this in standard form, and we need to, of course, get rid of this minus that is in here because the standard form assumes that b, the coefficient of x, is positive. So how do we do this? So remember, we're going to use the symmetry of the sine. So what do we know about the sine function? The sine function is an odd function, so that means you can take the negative out. Very good, honey. So this becomes minus sine of 2x. Okay? So notice that this is already in standard form because you can think of this as being 2x minus 0 plus 0. All right? It's just that, of course, we don't write that down. So then for this, we can immediately say what are a, b, c, and d. So let's see, what's the value of a in this case? So it's negative 1. The value of b, so the value of b is 2. How about the value of c? So c is 0, and the value of d is also 0. Okay, good. So now let's figure out what we need. So we need amplitude. Then we're going to figure out the period. Then we figure out the midline. And then we're going to figure out the phase shift. Okay, so the amplitude. How do we find the amplitude? Remember, this is absolute value of A, which in this case is positive 1. So the amplitude is 1. Now, what's the period? Remember, the period is 2 pi over B, right? So in this case, it's going to be 2 pi over 2, which is pi. So the period is pi. What's the midline? The midline is always y equals d, which in this case is y equals 0. So the midline is going to be the x-axis. And the phase shift, what was the formula for the phase shift? So that's going to be equal to, anybody? Remember, it was C over B, right? Remember, phase shift has to do with, so midline has to do with any vertical transformation that we're doing to the picture. Phase shift has to do with any horizontal transformations that we're doing to the picture. Okay, because C is equal to 0, this would be 0 over 2, which is just 0. So that means there will not be any horizontal transformations done to this picture, to the graph of the function. Okay, so that's how we find this information. Now let's go ahead and let's sketch. But before I do that, questions on finding any of these 4 items? Okay, so now let's graph. So remember, to sketch is easier to figure out where the main cycle is. So main cycle, you can either use the information that we have for the phase shift and the period to figure this out, or solve the inequality. I honestly prefer to solve the inequality because I think it's easy. I just take the stuff that is inside, and because I know that the sine function has period between 0 and 2 pi, the original function, this is what I solve, okay? Just take whatever is inside the function and write it between 0 and 2 pi and then solve for it. So here we divide by 2, and then we get that x is between 0 and pi. So this is our main cycle. Our main cycle begins at 0 and finishes at pi. Okay? So again, how can you figure this out? Well, if you look at the phase shift is 0, so that means we're starting at 0, and because the period is pi, that means that the length of your main cycle is pi. So you just add pi to the starting point, and that's how you get the beginning and the ending point. That's how you can figure out this cycle with this information here without having to do the inequality that I did, okay? But I personally like to do the inequality. All right, so this is the main cycle. Now remember what we do. We split it into 4 pieces, okay? And because the 4 pieces are equal, then the total length is pi. Then what's the length of each of the pieces? What will be the length of one little piece here? We also have a formula for this, but you can just think about it, right? So it's pi over 4. But remember what was the formula? What was the formula? Period, whatever the period is, divided by 4, which in this case is pi over 4. The period is pi, okay? But think about it. You have your interval, so the length of the interval divided by 4. It's just that by definition, the length of the cycle is the period, okay? So that means that this is pi over 4. Then you add an extra pi over 4, you get pi over 2. Then 3 pi over 4, and then pi. Questions on how to get the main cycle? All right, so now that we have the main cycle, then we are ready to graph. So remember, you should always draw a couple of cycles, okay? So once we have our main cycle, then we should do a couple more. One to the left, one to the right, something like that. When it's too tedious, then we just do, okay? We just do 2 cycles. Anyways, so let's see, I'm gonna give myself some space. So I'm gonna put 1 here and -1 here, because that's our amplitude, right? And we're not doing any shift. The midline is 0, so between 1 and -1. Then the main cycle goes from 0 to pi. I'm gonna put pi here, and then split into 4 pieces. So that's pi over 4, pi over 2, 3 pi over 4, and then pi. And then we put our key points, okay? So let's see, what are our key points? Remember, the sine begins at the midline. The midline is y equals 0. So we begin at the midline, and then we go up. So we have our amplitude. So let me just put this. Our graph is going to be trapped between these two horizontal lines. So in the sine, the key points are middle, then up, middle, down, then back to the middle. Okay, and then just sketch with the sine shape. So this is how the main cycle looks like. Notice that this was horizontally compressed by a factor of 2. Remember, normally this will happen over a period of 2 pi, but now we did this over a period of pi. Okay, and now we just have to copy and paste the same picture to the right, and since it's not too bad, you should copy and paste it also to the left. So I'm going to do a couple of more cycles. The next cycle will go from pi all the way up to 2 pi, right? Remember, the period has length pi. So every pi, you're going to have the same shape repeated over and over again. So split this into 4 pieces. And what are the values? Keep on adding pi over 4s, okay? So pi is 4 pi over 4. So this one is 5 pi over 4. Then 6 pi over 4, which is the same thing as 3 pi over 2. Then 7 pi over 4. And then point is 8 pi over 4 or 2 pi. And now we just keep on doing it. So middle, up, middle, down, middle. And then, keep on going this way. And since it's not too bad, we should just, do it again here to the left. So split it into 4 pieces. And negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. So middle, up, middle, down, and then back up. And then, you graph. And this keeps going this way to the left. All right, questions? Questions on this? Okay. So are you guys okay? If you have questions, you need to ask because I'm not gonna be graphing these anymore. Do you have questions? I know Christine is okay. Is everybody else okay? All right, great. Okay, so let's see. Let's do B. So we have negative 3 cosine. Yes, remember, Maria, we have 2 examples, right? So we have 1 and we have 2. So now we're gonna do the second example. You okay? All right. So the next one will be, so what was it? Negative 3 times cosine of negative 2x. And then did I put plus or minus pi? Plus pi minus 1. Okay. Plus pi minus 1. Okay, so let's see. The first thing, remember, first thing is to make sure that this is in standard form. Is this in standard form? Okay. So let's see. What restriction do we have on B? Remember, what do we say about B? B has to be positive, right? This is very important. It's very easy to ignore, but this is very important. Otherwise, all of this technique will go downhill because then the formulas are not going to work. You need to have the formulas assume that B is positive. You okay with this? All right. So this is not in a standard form because there is a negative here that does not belong. Okay. So we need to get rid of it. So how do we take out the negative? Well, we have to be careful how we do this. Okay. So the first thing that you need to do is you factor out the negative. Okay. You factor out the negative inside the argument. So let's see. Be careful. Let's factor out the negative. I'm going to factor out the negative, so you're going to have 2x minus pi. Do you understand this? Okay, now that we factor out the negative inside, we use the symmetry of the function. What do we know about the cosine function? Is it even or odd? Remember, we discussed symmetry, so cosine is even, very good. And what does that mean? What does that mean about an even function? What happens to the negative? Remember, even means that when you plug in negative x, this is the same thing as the function itself. That's what it means to be even. Okay, this is the notion of even. So whether you plug in x or negative x, it doesn't matter. You get the same y because your graph is symmetric with respect to the y-axis. So the minus is just gone from the cosine. Not like the sine, because the sine is odd, you have to take the minus out. Okay. In this case, because the cosine is even, the minus is gone. Okay. So cosine of, so this would be negative 3 cosine of 2x minus pi minus 1. So you can just get rid of this minus right here because the cosine is even. It's important to factor it first because otherwise you're not going to see it. You see how now we have a minus in front of pi instead of a plus? So that's why you need to factor the minus first before you do this step. Okay? All right. Questions? Questions on this? All right, so now we have it in standard form, so we are ready to write down what we need. Okay, so now we can write A, B, C, and D. So A here is going to be negative 3, B is positive 2. What is C? What's the value of C here? Okay, Sarah says negative pi. Look at the standard form. What's the standard form? The minus is already part of the formula, yes? So C is what you have after the minus. Okay, so you do not include the minus. If you had plus pi, then okay, C would be minus pi. Because plus pi, you will write it as minus minus pi. Does that make sense? All right, so you have to be careful here. So C is pi, and D is negative 1. Everybody okay with this? All right, so once you have this, then you can immediately write the 4 things that we asked. So the amplitude, the period, midline, and phase shift. Because we have formula for all of this. So remember, amplitude is absolute value of A, which in this case is positive 3, right? The period is going to be 2 pi divided by B, which in this case is, probably wanted a different period than the one. Would you like to do it with a different period? So it's okay if it's just that this period is the same as the one above. So I was just thinking that probably it's better to have a different period so you see more examples. Would you like to have another period? Because we're gonna get pi now. All right, so let's see. What period do you want? Actually, let's see. We haven't done any example. All our examples have had pi's on them. Okay, for the period. So let us have a period without pi. Okay, so how do we do this? And that's when if you put a pi in the coefficient. So for example, we can say, let's put in the original function, the original problem. We have negative 2. Let us actually switch it for And let's put a 1/2 pi in here. Let's make it more interesting. Let's put a negative 1/2 pi. So a negative pi over 2. Let's put it like that. Negative pi over 2. So that means that we're going to have here negative pi over 2 x. So this would be then pi over 2 when you factor out the minus. So we're going to have pi over 2 here. So that means that our b is going to be pi over 2. Nothing wrong with that. Okay. Okay, good. So now we're going to divide this by pi over 2. So that would be 2 pi divided by pi over 2. So the period is going to be 4, right? So now the period is 4. Do you understand what's happening so far? Okay, I just changed it, to make the problem more interesting, and so you have a different type of examples than the one that we have seen. And then midline, the midline, remember, is y equals d. So that would just be y equals -1. And the phase shift is c over b. Okay, so let's see, what is c in this case? C is pi, and b was pi over 2. So the phase shift equals 2. The pi's cancel out. Okay. Questions in finding these 4 quantities? All right. So next, I'm gonna. Yes, Maria.
Could you repeat how you found the period?
Okay, I couldn't hear what you said because you were breaking up a lot. Can you try again? Is it just for me or is it breaking up for everybody? I couldn't hear. So yeah, so try again, Maria. If it happens again, then type it. Okay, perfect. So okay, the period. Remember, the period is 2 pi over b. So b now is pi over 2. So you just do 2 pi divided by pi over 2. Okay, let me just do one more step. So remember, how do you do this? You multiply and then you have to flip the fraction in the bottom. So the pi's cancel and you get 2 times 2, which is 4. No, the period is 2 pi over b. The period is 2 pi over b. That's the formula for the period. Are you okay? All right. Okay, so now let's figure out the main cycle. So once again, in my personal opinion, it's just easier to write down whatever is in the argument of the function, which in this case is pi over 2x minus pi. And then the cosine, I know, is always between 0 and 2 pi, and then I'm going to work it out from here. But you can use this knowledge to construct the main cycle, okay? This is telling me that we're going to begin at 2, because that's a phase shift, and then the main cycle will be from 2 to 6, because the period is 4, so 2 plus 4 is 6. So I know it will be from 2 to 6 by looking at this information that we have already. But, if you don't feel comfortable doing that, then the inequality will tell you as well. Anyways, solve the inequality. And this way you also check to make sure that the formulas, the values that you came up with, they are correct, okay? So we get the pi over 2 minus x has to be between pi and 2 pi, pi over 2x, pi over 2x, between pi and 2 pi and 3 pi. Now we multiply everything by 2. So we get 2 pi between pi x divided by 6 pi, and now we divide everything by pi, to solve for x. So we get that x must be between 2 and 6, okay? So as we mentioned, here we have 2, 6, so that's the main period. That's what the main cycle is going to be, and now we just need to split this into 4 equal pieces so that we can figure out the key points, okay? So split into 4 equal pieces. Now, because the period is 4, then that means period divided by 4 is 1, so this is 3, 4, 5, 6. So I guess it's easier. These ones are nicer because you don't have to deal with the pi's and so on. So it's kind of easier to figure out the little numbers that go in the interval. All right, so again, remember the length here is period divided by 4. The period is 4, so 4 over 4 is 1. So we just keep on adding, incrementing 1 unit at a time. Are you okay with the main cycle picture? All right, so it's time to draw. Let's see. So we put our X and Y. So it's going to be shifted to the right. So I'm going to do big X-axis. So let's see, we're going to begin at X equal 2. So let's declare that this is 1. So this one's going to be 2. And 3, 4, 5, 6. So from 2 to 6. And then all of these guys, they have to be here. They're important. Next, we should put our midline. Okay. So what's the midline? The midline is y equals -1. Say, okay, even if it's not like that, let's just put it there. And I'm gonna put the midline right here. This is a midline, and then remember to decide, you look at the amplitude to decide what's the highest point and the lowest point on the graph, starting from the midline. So what's the amplitude? The amplitude was 3, so that means we need to go 3 units above the midline and 3 units below the midline, okay? So if the midline was at -1, then we need to go up to 2, so 1, 2. And then we need to go down to -4 because the amplitude is 3. So -2, -3, -4, right here. So that means that our graph is going to be between y equals 2 and between y equals -4. Does everybody understand this setup so far? Okay. So now, once we begin with this, then we put our key points. Okay. So remember, we already have the main cycle. What are we drawing? We are drawing a cosine function, and you need to understand that a is negative. So what does that mean? It means that we need to flip the graph, right? So cosine normally begins, it would normally begin up here, the middle, the down, and so on. But now we just have to flip this behavior because we have a negative in front. Remember, this caused the graph to be flipped as one of the transformations. Do you understand this? Because a is negative. That negative is responsible for flipping the graph. And actually, you see, we did not do that in the first example. Okay, so let's finish this one, then we need to fix this one because this one should have been done the other way. Now that I'm saying this, we should have gone this way, okay? Because of the negative. But we're gonna fix it later. Let us just finish this example. Anyways, we have a -3 in front of our function. This negative right here, what it causes is that it makes the graph to be flipped. Do you understand this? Okay, so remember, for cosine, the location of the key points were up, middle, down, middle, up, and then you use these to graph. But this time we need to flip this, so it's gonna be, instead of up, it's down, then middle, then up, middle, and then down. And actually we're gonna have something like this blue graph, okay, because of the negative. So this is what we're gonna have. We start down instead of starting up. Okay, so let's see. Remember, we begin at 2. So we start down here. Then we go to the middle. Then we go up. Then we go to the middle. And remember, when I say middle, I mean the midline, whatever that midline is. And then we go down. and we draw here our main cycle. Okay, so the scale is a little bit strange, but okay, I'm very uncomfortable with this. So we have to turn around a little bit. Okay, so questions about this first part, this main cycle right here. Questions on this? Do you need any explanation for this main cycle? Okay, so now we should just copy and paste this to the right and to the left. Okay, so we should do a couple more. So remember the period is 4, so we should go 4 more units, so up to 10. Let's put 10 here. So split. So that would be 7, 8, 9, 10. So then you just repeat. So we are down, then that's middle, then up, then middle, and then down. Then this just continues this way. Okay, passes through this point and then just keeps going that way, and then to the left the same thing. So it's 4 to the left, so we should do -1, -2, and then begin down here, then middle, and 0, we are up, then middle, and then down. Okay. It keeps going that way. Okay. So it's just that the inflection point kind of makes it a little bit uncomfortable, and since I'm doing it too big, it's kind of hard to draw it. Anyways, questions on this one? All right. So let me actually back up, and we should fix this one, okay? Because again, the graph that we did was without the minus, okay? The graph that we did in the first example was, we kind of ignored the fact that there was a negative in front of the sign. I went ahead and graph it that way, okay? So really what we should do now is we should just flip this picture. So the graph is really the other way around, okay? So that's what I'm gonna do. I'm gonna flip the picture, but I mean, the intervals will change, they are the same. You just need to flip the picture. So since we have the sine function, let's just change the key points. What changes is what was on top now is in the bottom, and what was in the bottom now is on top. Okay, so we begin at the middle, then we need to go down instead of going up. So we go down, then middle, then we go up, and then back to the middle. So it will look like this. And now we just copy and paste. Okay, so just down again, middle, up, and then back to the middle. Keep going this way, and then same thing to the left. So it's gonna go down, middle, then up, and then back to the middle. keeps going that way. Okay. All right. Questions? You understand what was happening, right? Compared to the previous one that we did not take into account the minus. So that's why I'm fixing it now. All right, questions about graphing sine and cosine. I think we have done plenty of examples with this. Last time we did a couple, and then now we did two more, and the last one that we did actually has no pi's in the x-axis, because this happens when your b has a pi, then that makes the labels of pi to disappear because of the period. The period becomes an integer. So it's nicer to work with that way. But if your b doesn't have a pi, then you need to deal with all the pi's when you're breaking up your integrals. Okay? All right. I'm gonna move away from here. Any last questions? Okay, perfect. Okay, so now that we understand how to do sine and cosine, then graphing the other functions is not really that complicated, because we already have the basics for sine and cosine down. So let's see, let me first talk about tangent. Once I give you the graph of tangent, then you will see the graph of cotangent is going to follow very similarly, okay? And then lastly, I will show you the graph of secant and cosecant. All right, so first we want to graph tangent. So the graph of y equals tangent of x. And to do this, I'm just gonna analyze the function a little bit. In particular, remember, tangent is sine over cosine, okay? So when you want to graph a function, the domain is very important. And remember, in this case, we don't want the denominator to be 0. So something that we don't want for sure is cosine of x to be equal to 0, okay? So we need to solve this little equation. This is a very simple example of a trigonometric equation, which we're going to be discussing soon. All right, so we need to solve this equation. Cosine of x equals to 0. What are the solutions to this? Remember, you may want to use the unit circle to help you out a little bit. When is cosine equal to 0? That happens on the points. That's whenever you have a point on the unit circle with x equals 0. So there are two possibilities, right? Up here or down here. That's the point 1, 0, 0, 1, or 0, -1. And as you know, this corresponds to pi over 2 or 3 pi over 2, and actually any coterminal to these two, right? So this happens whenever x equals pi over 2 plus 2k pi, because that's any coterminal to it, or 3 pi over 2 plus 2k pi. Here I'm just adding multiples of 2 pi, okay? Completing revolutions. Here k is an integer. Do you understand this? So these are values that we need to eliminate from the domain of tangent, because this is what makes the bottom equal to 0. Are you okay with this? Okay, here all I'm doing, so k is an integer. So here k is an integer, is any integer. And all I'm doing is when I add 2k pi, what I'm adding is multiples of 2 pi, or subtracting. If k is negative, I'm subtracting multiples of 2 pi. It's a full revolution, so this is a way of saying coterminals. So for example, think about the circle, and let's say that you have this angle right here. Let's say this is theta. What would be a coterminal angle to theta? Well, you just add 360, right? Or 2 pi in this case. And then you're going to get this other big angle. This would be theta plus 2 pi. Now, what would be another coterminal? Well, you can add 4 pi. So that's one revolution, and then the second revolution, and then an extra angle, right? So the green one here would be theta plus 4 pi, which is 2 times 2 pi, right? So that means 2 revolutions, and then you stop. And so on. You can do as many revolutions as you want, and then as long as you stop in the same terminal side, remember you have a coterminal angle. But you could decide to use negative case. That means you're doing revolutions clockwise, right? But it's the same thing. You're gonna have a negative angle, but as long as it's coterminal to our angle, that's okay. So the 2k pi is a way of writing coterminal angles. This is gonna come up a lot when we're solving equations, so you need to start getting used to this. So this means that the cosine is 0 at pi over 2 and any coterminal to it, and the bottom one says 3 pi over 2 and any coterminal to it. The 2k pi stands for the coterminal part. Do you understand this? Okay, now there is a nice way of combining these two answers, okay? Because actually, if you think about it, also you can see it from the picture, you see we're actually jumping from pi over 2 to 3 pi over 2. So you think about it, you're jumping between y equals 1 to y equals negative 1. So you're doing this. You're going from here to here, and then from here to here. And once you are in any of those points, how do you get, what do you need to add to your angle to get to the next one? All you have to do is add pi to it, right? Remember, pi is a straight angle. So to go from pi over 2 to 3 pi over 2, you add pi. Then you add another pi and you will get a coterminal to pi over 2. Another pi, you get a coterminal to 3 pi over 2, and so on and so forth. So by adding pi, you're jumping from the top to the bottom and from the bottom to the top. So moral of the story, we can actually collect all of this by saying that x is actually equals to pi over 2. Let's start there, and then we just add multiples of pi. If you add 1 pi, then you're going to be at 3 pi over 2. If you add 2 pi, you're back at pi over 2. If you add 3 pi, then you will end up in 3 pi over 2, and so on. Do you understand this? That by adding pi, you're just jumping between these 2 points on the unit circle. Okay, now this makes it easier because now I can factor out pi over 2. And if you factor out pi over 2, we're just trying to understand what these points are when in the graph, okay? So when you factor out pi over 2, we're going to get 1 plus 2k. Or in other words, 2k plus 1 times pi over 2. So moral of the story, what do we have here? These are odd multiples of pi over 2. So when is cosine equal to 0? The cosine is going to be equal to 0 at odd multiples of pi over 2. In other words, what are the values that we don't want? So we don't want x to be, for example, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. Those are odd multiples, but also the negative version of this. Negative pi over 2, negative 3 pi over 2, and so on and so forth. So at all of these values, we need to exclude them from the domain of tangent because at all of these points, there are infinitely many, and when you plug in, you're going to get 0 in the denominator, and that's not good, okay? So what's the domain? Again, it's very easy to read this description from this formula right here. Remember, 2k plus 1 is a way of talking about odd numbers, okay? So it means odd multiples of pi over 2. So the domain would be all real numbers x, such that x is different than pi over 2 plus k pi, where k is any integer. And another way that we typically want to write it is x is not an odd multiple of 2 pi. So we can rewrite this as 2k plus 1 times pi over 2, with k any integer. Okay? All right, so this is the domain. Now we need to say, okay, what happens at these points then? The function is not defined, but what if we get close to it? And you have some experience with this already. Remember rational functions because this is a fraction, right? Let's analyze pi over 2, and then the same thing that we see at pi over 2, that's going to be happening whenever we get close to any of these other points. So I'm just getting pi over 2 as a representative example here, okay? So what happens when we get close to pi over 2 from the right, and what will happen when we get close to pi over 2 from the left? So imagine that you have your angle here. We're getting close to pi over 2 from the right. What does that mean? Let's go to the unit circle. It means that we're getting close to pi over 2 like this, right? So we are in quadrant 2, and we are going towards pi over 2, but from quadrant 2. So what do we know about tangent in quadrant 2? Is it positive or negative? What do we know about pi over about quadrant 2? Then is negative. Now, remember, as when you get close to pi over 2, the bottom gets close to 0. So that means we're going to have some sort of infinity, because the top, the number, sine, it approaches 1, right? This fraction, tangent, which is sine over cosine, it approaches to 1 on top, and it approaches 0 in the bottom when you're close to pi over 2. So 1 over 0, this is infinity, as we discussed when we did rational functions. So that means that we're going to have a vertical asymptote, right? So it's going to be a vertical asymptote at pi over 2. And moreover, we need to decide what's the behavior. Is it positive or negative infinity? Well, when you approach pi over 2 from the right, because we are in quadrant 2, you know tangent is negative. So you're going to have the tangent of x is going to approach negative infinity, because it's negative. And when you approach pi over 2 from the left, so you are less than pi over 2, that means when we do that, if x is here, we are in quadrant 1, tangent is positive, so the tangent of x is going to approach positive infinity. Okay? And this is going to be the same behavior on the other points as well. To the right is going to be negative infinity, to the left is going to be positive infinity. Okay? So and notice that pi over 2 was just one of these guys. So at every one of these points that we figured out that cosine is 0, this behavior is going to be happening. So the graph of tangent is going to have infinitely many vertical asymptotes. So vertical asymptotes for the tangent function is the collection of all x of the form 2k plus 1 times pi over 2, where k is any integer. So infinitely many vertical asymptotes, and they all happens at odd multiples of pi over 2. Okay, so let me start showing you the picture, at least of the asymptotes. So when you're gonna graph the tangent function, we're gonna have the following. So we're gonna have 0. Here is pi over 2. Then we have, let's say, pi. Then we're gonna have, give myself more space, pi. Then we have here 3 pi over 2, and so on. So we're gonna have vertical asymptote here. We're gonna have vertical asymptote here, and it keeps going this way. Okay, every pi, right? Every pi you're gonna have a vertical asymptote. Then here to the left you're gonna have negative pi over 2, another vertical asymptote, and then negative 3 pi over 2, another vertical asymptote. Here in the middle we're gonna have negative pi, and then keeps going this way. So there are infinitely many vertical asymptotes for the tangent function, and now let's try to figure out what happens in between each of these vertical asymptotes. Okay, so questions on the vertical asymptote part? Questions on this? Okay, so remember the behavior that we saw. To the left is positive infinity, to the right is negative infinity. So it's gonna be going up like this to the left, right? So up like this, then up like this, up like this, to the left, and then to the right is gonna be going down. So it's gonna be going down like this, and down, down, down. So this behavior is gonna be happening around every vertical asymptote. Up to the left, and to the right of it is gonna be going down. Okay, so another thing that's important are the zeros of the function. And remember, the tangent function is 0 whenever sine is 0. So let's find the x-intercept. So when is tangent of x equals to 0? This happens whenever sine is 0. And if we go back to our unit circle, when is the sine function equal to 0? Remember, sine is given by y, so that's going to happen exactly at these 2 points, right? So at 1, 0 and negative 1, 0, that's when sine is equal to 0. So this happens whenever x is either 0 or pi. But remember, we need to throw in coterminals. So we can actually combine these two by just saying multiples of pi, because you have 0, pi, then 2 pi, 3 pi, 4 pi, and so on. So this can be combined nicely as multiples of pi, or case any integer. So moral of the story, the function is going to be 0 at 0. So let me spell it out here. So that's 0, pi, 2 pi, 3 pi, and so on, negative pi, negative 2 pi, etc. Okay, so I will be at 0, then a pi, etc., then negative pi, and so on. Okay, keep going to the right, keep going to the left. So you should start to kind of form some sort of picture in your mind if you want. Look at the asymptotic behavior, look at the zeros. The next thing that we can do is, for example, let's pick pi over 4. Why? Because that's a very important point. Tangent of pi over 4 is 45 degrees. We know that's equal to 1. Okay, so that's going to give you a value here. And if you plug in negative pi over 4, because tangent is an odd function, that's going to be negative 1. So we have it down here. So you should already get a feeling of what's going to happen. Okay, so the tangent function has this shape. It looks like a cubic. Okay, it looks like a cubic, but it's trapped between two vertical asymptotes. And then this actually keeps on repeating all the time. So now right here, this in the middle, we have this point, and then here we have negative 1, and then it just keeps on repeating. It goes up, and this one goes down here. Okay. And so on. So it keeps going this way, and then to the left is the same story. It looks like a cube. All right, questions on the graph of tangent? Questions on this? All right, so by looking at this picture, we can actually see that the tangent is just infinitely many copies of this shape that we see here in the middle. Okay, if you look at the picture between negative pi over 2 and pi over 2, then that shape that we see here, which looks like a cubic, it just keeps on repeating over and over to the right, over and over to the left. Okay, so that actually, what I draw in blue is what we consider the main cycle of the tangent. Okay, and you can actually see that the period now is pi. Instead of being 2 pi, the period of the tangent function is pi. So note the period of y equals tangent of x is pi. So every pi values, it's true that they repeat every 2 pi, but we have a smaller number that the tangent repeats, which is pi. So in other words, tangent of x equals tangent of x plus pi for all x. Okay, so every pi, the value of tangent is going to repeat itself, therefore the period is pi. And that's exactly what you see here in the picture. The length of the cycle is exactly pi. From negative pi over 2 to pi over 2, you have a length of pi. And then you add pi again, you get the next cycle from pi over 2 to 3 pi over 2, etc. And same thing to the left. All right, and the range, we can see the range is from negative infinity to positive infinity. We can see from the graph that is an odd function, and so on and so forth, as we already knew from before. Okay, so let me give you the formulas, and then I'm going to give you the graph of cotangent, which is a very similar idea, because the only thing that changes for cotangent is that is now cosine over sine. So what's going to happen? We're going to have vertical asymptotes as well, but instead of being whenever cosine was 0, it's going to be whenever sine is 0. So for cotangent, our vertical asymptotes are going to be a multiples of pi, right? And then our intercepts will be wherever the tangent has the asymptote, so at odd multiples of pi over 2. So it's the same picture, but actually we're going to shift it a little bit, okay? All right, let me just write this down. So for the general function, so general form, so the general form of tangent is going to be, a times tangent of bx minus c plus d with b positive, okay? So in this case, it doesn't really make sense of talking about the amplitude of the tangent, because the tangent, the range is from negative infinity to positive infinity, so there is doesn't make sense to talk about the amplitude, but we do talk about the period of tangent, we do talk about the midline, and we do talk about the phase shift. So the period is going to be the same formula as before, but instead of being 2 pi over b, this time it's going to be pi over b. And it's because the period of tangent is pi. It's not 2 pi, like sine and cosine, okay? Midline is going to be the same. It's going to be d. Notice that in this case, for this graph, the midline is exactly the x-axis, right? But in general, if you have some transformations, the midline is going to be y equals d. And then the phase shift is going to be the usual one, okay? It's going to be c over b. And then remember, where if c is positive, then you shift to the right. If c is negative, then you're going to shift to the left. Okay? All right. So, questions on these formulas? Questions on this? The only thing that changed here was that for the period, instead of a 2 pi, we have a pi on top. That's it. But other than that, the rest is the same as before. Do you have questions? All right. So, and let me give you the information for the cotangent, and then we'll do examples, okay? So, cotangent. So, graph of cotangent is actually, very similar to tangent. Remember, cotangent is cosine over sine. So it's just like tangent, but then we just need to switch some things. Now the issue is whenever sine is equal to 0, and then the intercepts are whenever cosine is equal to 0. So as usual, domain is going to be all x. So what is it that we don't want? We don't want sine to be 0 in this case, and we already did the work above. So this happens when x is multiples of pi. Okay? Any integer. So the domain is going to be all real numbers x, such that x is different than k pi, with k an integer. And then when is it, and at this point, we're going to have vertical asymptotes, okay? So are all x's such that x equals k pi. These are the equations of our vertical asymptote. So let's quickly figure out the behavior. So we can pick a representative, let's say x equals 0, right? So let's put our unit circle here. So when we get close to 0, we can do this with values bigger than 0, or we can do it with values less than 0, okay? So let's see, here we have 0. We know we're going to have a vertical asymptote right here. Now, what if we approach to 0 from the right with values bigger than 0, or what if we approach to 0 from the left with values less than 0? Here we just need to analyze the sign of cotangent. In quadrant 1, everybody's positive. So when you approach 0 from the right, that's quadrant 1. So that means cotangent of x is going to approach positive infinity. And when you approach 0 from the left, then that's quadrant 4, and cotangent is negative in quadrant 4. So cotangent is going to approach negative infinity. Okay. All right. And then the intercepts. Remember, the x-intercept is going to happen whenever cotangent is equal to 0. And because cotangent is cosine over sine, this is whenever cosine is 0. And as we know, this happens at odd multiples of pi over 2. Okay, so we are ready to graph. So it's going to be very, very similar to what we have for tangent. It's just that now we need to move the vertical asymptotes, okay? Instead of being at odd multiples of pi over 2, the vertical asymptote is going to happen at multiple of pi's. So at 0 we have one, then at pi we have another one, then at pi we're going to have another one, and so on. 3 pi, etc. And then let's say negative pi, negative 2 pi. So vertical asymptote in all of these places. And then the main cycle, we're going to have it between 0 and pi, because now the intercepts are going to be odd multiples of pi over 2. So they will happen at pi over 2, 3 pi over 2, 5 pi over 2, and so on. And then here, negative pi over 2, negative 3 pi over 2, etc. And now what's the behavior? What's the asymptotic behavior? So to the right, it goes to positive infinity, and then to the left of the asymptote, it goes to negative infinity. So it's going to be like this. And then we just keep on having this behavior. So very similar to tangent. So to the right and to the left. And once again, the main cycle is this one right here. So this right here is the one that we're going to use as our main cycle. Okay, questions on the graph? Questions on the graph of cotangent? So we can see that the period is pi. So the period is pi and so on. So very similar to time, okay? So let me give you the general formula. So general form. So the general form for cotangent is A cotangent of bx minus c plus d, where b is positive. Again, here there is no notion of amplitude for cotangent because the range is from negative infinity to positive infinity. And then we have formulas for period, midline, and phase shift. And then the period is going to be pi over b, just like for tangent. Here y equals d, and phase shift c over b, the same as before. Okay. So you know, there are some key points that you should have. So this is pi over 4, and here we have 3 pi over 4. So at pi over 4, cotangent is equal to 1. And then at 3 pi over 4, cotangent equals negative 1. So it's helpful to know this, because these are the points that we're going to be using to graph. Okay, just like for the cubic, to graph it correctly, you should have 3 points at least. One at the flexion point, and then one on each side. Okay, and this point, they just keep on extending to each of the little pieces that we have. All right, so now that we have this, let's go ahead and let's do some examples. let's see, I'm gonna graph a tangent function. If we graph a tangent function, that should be enough, because as you can see, cotangent is very similar to tangent. Okay. All right. Questions before I do the example? All right. So let's see. As an example, sketch. Well, let's say find period, midline, and phase shift, then sketch. Okay. All right. Let's see. So the function is gonna be y equals -2 times tangent of pi x plus pi minus 1. Okay, so let's do this one right here. So -2 times tangent of pi x plus pi. So the first thing that we need to do is make sure that this is in standard form. And remember, the standard form requires a minus instead of a plus. So we should just fix this a little bit and write it as minus minus. And this is just so we can get the quantities correct. Okay. So notice that A actually plays no role in the formula, so there is no need to worry about A at all. All we really care about is what is B, what is C, and what is D. So here B is pi, C is -pi, and D is -1. All right, so with this information, we are ready to write down the period. We can write the midline, and we can write the phase shift. So remember, period is pi over b, which in this particular case happens to be pi over pi. So the period is 1, okay? And the midline is always y equals d. So here is y equals -1. So this is a tangent function that was shifted down 1 unit, okay? Phase shift is c over b, which would be -pi over pi, so that's -1. So that means that the function is going to be shifted to the left 1 unit. That's what this -1 tells us. So left 1 unit. All right, questions on how to find these three quantities? Remember, there is no amplitude for tangent or cotangent. It makes no sense because the range is infinity anyways. Questions?
Professor?
Yes?
I thought the formula to find the period was 2 pi over b.
That's for sine and cosine. If you look at tangent, I wrote the formulas here. It's pi over b. Because remember, the period, what you put on top of the fraction is the period of the regular function instead of the general formula. And for sine and cosine, the regular function has period 2 pi. That's why we had a 2 pi over there. But here, the tangent function, the period is pi. So that's why for the general form, we need to have on top a pi instead of a 2 pi. It's pi over b. Do you understand this?
Yeah, I got it. Thank you.
All right, no problem. Okay, so now that we have these values, then again, as usual, the main cycle. Now remember, for tangent, the main cycle is always between -pi over 2 and pi over 2. So we need to do the adjustment accordingly, okay? So we had here pi x plus pi, that's what we had in the argument. So this is between -pi over 2 and pi over 2. This is the main cycle of tangent. So let us figure out this function that we have, where will the main cycle go? We know it have to go left 1 unit, okay? But this inequality is gonna tell us. So subtract pi, all right? So we have pi x is gonna be less than or equal to -pi over 2 and -3 pi over 2. Then divide everything by pi. So the pi's are essentially cancel out. So we get x is between -3/2 and -1/2. Okay, so that means that we're gonna have here -3/2, then -1/2, and this would be our main cycle. So as usual, remember we're gonna have 4 pieces, okay? So split into 4 equal pieces, and then the rest is exactly the same. So the length here, L, is gonna be the period, which is 1 over, so the period over the length of the cycle divided by, so over 4, because we're dividing it into 4 little pieces. So the length is gonna be 1 over 4. So remember, period, that's the length of the cycle divided by 4. So we get a period of 1, so that's a quarter. Okay, so -3/2 plus 1 over 4 to figure out each of the little pieces. What is this? So 3/2 is the same thing as saying 6 over 4. Okay, so -6 over 4 plus 1 over 4, that's going to be -5 over 4. Then another 1 over 4, that's -4 over 4, or -1. And then -3 over 4. And then another 4, another 1 over 4, that would be -2 over 4, which is -1/2. So we are good. Questions on the values for the main cycle? Okay, so now we draw. So let's see, this is being pushed to the left. So I should give myself some space to the left. All right, so it's gonna begin at -3/2 and finish at -1/2. So let's say that this is -1/2. So I have to do 1, 2, 3, 4. So this would be -3/2. Okay. Now let's put the midline. What is the midline? The midline is y equals -1. By the way, the midline, that's exactly where these inflection points are going to happen. The inflection points are the ones that you see here where the function changes concavity. Those x-intercepts in this special graph, those are the inflection points, okay? Of course, if we have a midline that's different than the x-axis, that's going to go up or down. In our case, going down to -1, okay? So we're taking this picture, we're shifting it down to -1, and then we're moving to the left 1 unit, together with some stretches that we already took care of by putting the values, because we got rid of the pi, okay? All right, so let's see. That means that the midline is -1, so if this was 1/2, then -1 is gonna be here. Okay, so remember we're gonna have vertical asymptotes at the beginning of the period, and we also have vertical asymptote at the end of the period, because our tangent is always between this pair of vertical asymptotes, right? The main cycle. And now we're gonna put our points. Let's see. Do we have any other information? No, that's it. So remember, we always begin from -infinity. So because the tangent, it looks like this. It looks like a cubic, okay? So we're gonna be down here at -infinity. Then the next point is gonna be on the midline, okay? And then we're gonna finish at +infinity. So we're gonna have this sort of shape. Now let's see, -infinity. Then we are here on the midline. No, that's not correct. That the one in the middle is the one in the midline, which is this one right here. Then the -5 over 4. So you understand what those other 2 points are. Those are the pi over 4. That's the same thing as saying pi over 4 and -pi over 4 that we have in here, from left to right. So that's this point and this one right here. So our key points are gonna be the following. So we have the -infinity, then one here, then another one in the midline, then another one here, and then the +infinity. So then, you know, when you're graphing, you follow this shape. These are our key points, okay? The end behavior, and I mean the behavior next to the vertical asymptotes, and then together with these 3 points. So one down, one middle, and then one up, okay? So, but to figure out that point, you can do 2 things. You can follow the transformations that we're doing, or easier yet, you can just plug it into the function. That's up to you. Okay. So for example, let's figure out the y value of -5/4. That's going to be somewhere here below the midline. And then at 3π/4, it should be, somewhere here above the midline. So let us try to figure out where that is. Or if we have a negative on top, you have to watch out because this graph may be flipped. And in this case, it is being flipped because of the negative. Notice that we have a -2. So really, this process now is all reversed. So it's going to be going this way because of the flipping. It's going to be going this way because of the flipping. And then it's going to go here. And this guy is going to go here. So our graph is going to look like this, okay? Because of the flipping. All right, so then let's go ahead and let's figure out what's the value of the function on -5/4. That's the easier way to do it. So f of -5/4, and then we're gonna figure out what it is at -3/4. So just plug in. So that would be -2 times tangent of, so the formula was pi x plus x. So it's gonna be -5π/4 plus pi, and then -1. Okay, let's calculate this. So this is tangent of -9π/4 minus 1. And as you know, tangent is odd, so that negative, I'm going to get rid of it. I'm going to bring it to the front, and it will cancel the negative. So this is the same thing as 2 times tangent of 9π/4 minus 1. So this minus, it came out and canceled with this one, okay, because the tangent is odd. Now, what's tangent of 9π/4? So this is coterminal with pi/4 because this would be 8π/4 plus pi/4, and 8π/4 is 2 pi. So that's the same thing as 2 times tangent of pi/4 minus 1. Tangent of pi/4 is equal to 1. So that's 2 minus 1 equals 1. So this is happening up here at 1. So let's see. Here we have this point. And then let's plug in -3π/4. But you know that the graph is symmetric. So once you find this guy, then the other one you get it for free. Because this distance here is 2. So if you go down 2 units, you're going to find it. You're going to verify it anyways. But this means that at -3π/4, then we have to go 2 units down. So it's going to be, the output should be -3. So -2, -3. Right here. We need to go 2 units down. Okay, but anyways, let's verify it so you convince yourself. So it will be -2 times tangent of, we're plugging in -3/4. So that's -3/4 pi plus pi minus 1. So we get -2 tangent of, so what is this? That's 4π/4. Okay, you guys should be complaining. When I add pi, that's -5 plus 4 pi, so this will be -π/4. Okay, then the minus go out, so this is 2 tangent pi/4. I mean, it's the same, but I mean, the value did not change, but the calculation was wrong. This here is -π/4, it's not pi/4. Okay, let me just leave it like that. Then 1. Then here we're going to get pi/4 positive, because -3π/4 plus pi is pi/4. And then we get here -2 times 1 minus 1, so that's -3, as expected. And then after we have these points, then we can just graph, okay? So once again, remember we were flipping, so the end behavior changes. Now we're gonna go to positive infinity on the left and to negative infinity on the right, instead of the other way around, and we can graph. Let's see, we have something like this. It's going down this way, then keeps going on this way. And then you just copy and paste now this picture to the other side. So let's see. Now we can just do it in a symmetric way. So we just go by a quarter, a little bit more. So we have to split this. Unfortunately, this is supposed to be the same as this distance, so the graph is going to be weird, but I'm not going to erase this. So we have to do a quarter and 0, then another quarter, and then 1/2. Okay, so we're going to come to infinity, then it's going to go here, it's going to go through 0 here, then we're going to have another vertical asymptote right here. Then 1/4 is going to be -3, and then we're just going to go down this way. Again, just that the scale is not too good, because I'm saying here that this is 1/2, but then I only gave myself a little piece of 1/2 here. Okay, so that's the reason why you see the second one to squeeze. But this, we don't have time to erase this. So, and then you just keep on doing this to the right, and then we keep on doing this to the left. Okay, questions on graphing tangent? Questions on graphing this tangent function? All right, so the point is that, it's just like the cubic, the shape, but you just need to understand where to put your vertical asymptotes, okay? And the easier way to do this is to recognize where the main cycle is. So the vertical asymptote, is at the beginning and at the end, and you just keep on copying this to the right and to the left, okay? And always remember the general shape. That's all. So on Tuesday, what's going to happen is I'm going to give you guys the graph of secant and cosecant, but you will rarely be asked to graph those. Really, the important ones are sine, cosine, and then you need to be aware of tangent. And then we're going to talk about inverse functions. But the inverse functions, I'm going to leave it for the last exam that we're going to do. We're not going to have inverse function for the next exam, because those require some more careful looking at it, and then I don't want to rush it. So the stopping point for the exam is going to be this, okay? The graph of the trigonometric function. So I guess on Tuesday I will give you secant and cosecant. So then you will be required to know the properties of those, but then that's it. But you actually have everything you need to prepare for the exam. So I'm going to put a review together. I'm going to send it to you by the end of tomorrow, so that you can start working on problems if you want to for test 3, okay? Anyway, test 3, remember, is at the end of next week, but so that you can have your own time to prepare. Okay, any questions? I'm going to stop here. No questions? Yes, Sarah?
So when exactly did you say the next exam would be? Just so that I have.
It's gonna be at the end of next week. So
Okay.
it will open up, let's say on Thursday, and then you will have until Sunday to do it. But we will have class on Thursday, okay?
Okay.
But it will be at the end of next week.
Okay, perfect. Thank you.
No problem. Okay, guys. So take care. Happy Thanksgiving, and then take a break, but then don't take too long of a break, because there's a lot of work to do. Okay. So I'll see you next week on Tuesday.